So let's look at this. This is a velocity time graph or speed time graph. It's not quite the same. Velocity is not the same as speed, but we're going to not bother talking too much about the difference between the two at this point. So a speed time graph or a velocity time graph. So it's saying the lines are showing what happens as to the velocity as time continues. So as we move along the time axis, what happens to the velocity? Well, the pink, the yellow, the this color here, red, I think, and magenta all go up. So we can't just say the yellow line shows the velocity is increasing because it's not clear enough. We need to differentiate between the two. If it's a straight line, the rate at which it's increasing is constant. So what is the rate of change of velocity? That's acceleration. So the pink and the magenta line are constant acceleration. The difference being is that the pink line has a higher constant acceleration and the magenta line has a lower constant acceleration. So that's first. The straight lines are constant acceleration. That means this must be constant, but it's going down. So if the velocity is decreasing, well, it's decelerating, isn't it? So that's a constant deceleration. The green line's constant deceleration. What about the orange line? So what would the orange line be? Right, so this flat line, this orange line shows me that the velocity is not changing, so it's moving at constant velocity or constant speed. The red line, this curve here, is getting steeper, which means the acceleration is increasing as time goes on. And the yellow line, the gradient is getting less steep, so the acceleration is reducing over time. Now it's worth comparing this with a distance time graph. This is one of the biggest issues with motion graphs. They often get taught as entirely separate lessons. Like this is distance time graph, and this is a velocity time graph lesson. And I think they really should be taught side by side and comparing because there's so much confusion happens between the two. So let's do it. Copy that entire graph, but this time it's going to be a distance time graph. So we've got this. I'm going to rub out that V there, and we're going to say that's going to be a distance time graph now. Okay, so let's write a D if it lets me. Come on, a D. So that's a distance time graph. Now, what do the lines mean? They won't mean the same thing, but because of course, let's look at it. Let's think of the orange line on the left. We're saying it's a constant velocity. That means it's saying that the velocity is changing as time goes on. Now it's saying the distance is not, sorry, the velocity was staying constant as time went on. Now it's saying the distance is staying constant as time goes on. So do you want to run through the different colors and what they mean this time? So apart from the orange line and the green line, every single one of them is moving forwards because as time goes on, distance is increasing. So the green one's a bit weird. Let's just briefly look at the green one before we compare the other ones that are going up. The green line is going down. Now, the only way distance could be reducing is, well, we have to define what distance we're referring to here. If it was like distance from home currently, then the way to reduce that distance would be to go home, of course. So if we're going, so we can say that the green one is representing something going backwards. So what about the other ones? If it's and all the straight lines, the green one would be going home at a constant velocity or constant speed. The pink and the red are going forwards at a constant speed. The pink one is going faster than this magenta one here. I don't know if I said red or anyway, that magenta one there. And then we've got the red curve. Well, that is gradually getting faster because the steepness is increasing. And so we can say that's accelerating. And the yellow one is decelerating because it's gradually getting less steep. Still going forwards because you can see the distance is increasing, but the rate at which it's going forward is reducing, so it's decelerating. The other way to think about this is that you can see the yellow one is approaching a flat line, and we know that a flat line means it's stationary. So we can see from that point also that the yellow one is slowing down. Okay, so we'll just stop the video there. That's a brief summary.